Okay, so my name is Richard Burrill. I'm the Technical Director at PensionDCisions. PensionDCisions was established in 2005. Collection of skills come together, wealth management, technology and data analytics. Essentially what we do is apply business intelligence technology to help people understand their pensions better. Why we're different is because we reverse the current industry trend that has a focus in terms of pension reporting on the inputs. So for example, if you get a pension benefit statement, it's probably a list of products that you may be invested in and their performance versus a product-specific benchmark. It may have the value of your pension pot at the beginning of the period and the value at the end of the period, but what it won't have is a single number that tells you what return you achieved on your pension. We reverse that, and instead of looking at the products, the inputs, we go straight to the underlying portfolios for every individual in that scheme. The reason that matters is because by doing that, we can give you one number that represents the return that you've made on your pension. If we can do that for every individual in our database, we can give you a second number which represents a comparison with people like you. So we can say you may have made minus 3% on your pension, and other people like you made minus 5.2%. So not only do you have a handle on that you don't currently have in a number that you understand on what's happening in your pension, you also have some context. So by taking this bottom-up approach, we can deliver that clarity and that impact. We can also tell you in a single number some sort of feel for your risk position and how much risk you're taking versus perhaps other people like you, or how much risk you're taking perhaps versus how much you thought you were taking with your appetite for risk. The flip side of that is to do that, to take this bottom-up approach, we have to boil down literally millions of pieces of data, underlying data. We have to boil those down to those simple insights, and then we have to distribute those insights to thousands of users. Our clients would typically be large companies that offer a large defined contribution scheme. So both the managers, the pension managers, trustees or FDs within that company, but also the individual members of that scheme. So in order to deal with that quantity of underlying data and boil it down to something that's meaningful to those individuals, we're very technology reliant. No one technology is going to allow us to do that economically. We have a combination of technologies, a stack that works for us, and right in the middle of that stack is Azure. You can see it represented slightly here. At the back end, we have SQL Server as our main warehouse. That's where all the heavy lifting is done in terms of the loading of the data, the cleansing of the data, and these are the underlying transaction data, member by member, month by month. So it amounts to a large volume of data that is loaded, cleansed, and aggregated on-premise via a SQL Server platform. Why is it on-premise? We need that level of control. We need to deal with that data in a way that has huge integrity, and in order to do that, we need the control that we get from doing it on-premise. The volumes in this case are predictable. When we take on a new data source, we know what volume we're going to get. So there's no specific requirement for us to have any elasticity in that. We know what volume we're going to get. We can deal with it and predict it. At the front end, the point of consumption of these insights, the people looking at the information that we provide, we want to do that in as visually and impactful way as possible. So we use technologies like Silverlight and WPF because they give us that ability to deliver these insights in a very visually impactful manner. Right in the middle is the distribution, and that comes from Azure. Why Azure? It gives us elasticity in that distribution, not just elasticity around the underlying infrastructure, not having to worry about, for example, how many servers we need to deal with demand, but it abstracts that elasticity up to the next level, to the services level. So the fact is that the sort of information we provide will be consumed at different rates at different points in the year. So typically at benefits renewal time, there's likely to be a spike on the interesting information we provide, we can have a shot at predicting that spike and the headroom we need. But what we don't want to do is have to build the infrastructure and invest in the infrastructure to deal with that spike up front. If we leverage Azure as our distribution capability around the middle of this stack, we don't have to worry about that. We know that Azure will handle that spike, and the user experience will remain consistent. So that's the basic architecture that we run, and it's a classic software plus services architecture. The on-premise back-end doing all the heavy lifting and dealing with the large volumes of data. The front end either channel to the audience either via a web application or a desktop application based on WPF, and this elastic distribution piece in the middle. So this is an example of one of the applications that we might deliver at the front end. This is clearly aimed at someone responsible for a group of investors rather than an individual, because what you see there is on the x-axis risk and on the y-axis return, and every one of those dots represents an individual and their risk-return position. So at a glance, if you're a trustee or a pension manager or an FD, you can for the first time see you can see what is in fact most important in relation to your scheme, what it's delivering for the members in it. Every one of those points, as I said, represents an individual. 2 coordinates. Behind each of those coordinates there are many months of data combined. Each of those months combines hundreds of underlying pieces of transaction data, so end balances for that individual across the products they're invested in, switches from one product to another, money coming into their portfolio at that point. So we boil down that underlying transaction data into monthly figures. Those months are combined to provide a period figure. Those period risk and returns are then combined onto this, which gives you a single picture across the entire pension community. There are good places and bad places to be on that graph. If you are, for example, older and closer to retirement, you probably want to be toward the left-hand end of the risk spectrum as opposed to the right-hand end. And similarly, if you're younger with plenty of years to retirement, you probably want to be taking more risk to give you the chance that your pension will deliver what you want it to. So as a trustee or as a pension manager, I can start to look at that cloud and zoom in on particular areas of it and see if I have groups of individuals that are in a place where perhaps they shouldn't be. I might use that information to target my communications to them or to explore further. To help me do that, I can color code these dots. I can color code them against any of the dimensions in the data set. We're just showing a couple here, age band, for example, or the number of years in scheme. I've selected number of years in scheme here, and immediately it gives me more insight because I can see clusters and I can start to ask myself what those clusters mean. The other thing that you can see it's doing is you can animate across dimensions. The obvious dimension to animate across is time, and that's what it's doing as we watch it. And that means that you can see how the health of your group of investors in terms of risk and return is changing over time, and you can relate that to events in the marketplace, or you can relate it to communication efforts that you've invested in, and start to measure the change in behaviour and results simply by animating the picture.